No. So, section 7.6, dealing with the natural log, we have a graph of log base e of x, and we have a graph of e to the x. So let's move on and see what we will do with these now. All right, so our title is natural log, and we'll be using my properties, and we will be solving equations with these. And here we have another sketch using a calculator of the two graphs that we just got. Y equals e to the x, and y equals natural log. So we've already seen those. Okay. All right. Simplifying a natural log expression. So what is 2 log 15 minus log 75 written as a single logarithm? So using log properties the same way we have done on the previous section. So I write natural log how many times? One. I write natural log 1 time. And I see a number in front of the log. What happens to that?
Goes to exponent.
So this becomes 15 squared. The subtraction becomes division when we use our properties to condense. And then what goes in the bottom?
75.
75. Well, what is 15 squared?
600.
No. 225 is right. 225 divided by 75. No, 75. Is what? 3. So this is the natural log of 3 in its most simple form. Okay, same properties we have been using. Any questions on that?
No.
Okay. All right. So I can go back. Do that. To do one of these. Try that again. All right. Let's make this. I'll have you do the hardest one, see?
Oh, yeah.
So, write each expression, what's each expression written as a single log? So we want to do this one, condensed. The original is 3 ln x plus 2 ln y plus ln 5. So, single log means we write ln 1 time. Ian, what do we get from this first one? X to the 3. Addition becomes? So times what? Y to the? 2. Yep. Times? 5. That's it. We're done.
Oh, yeah.
Okay? Okay, solving an exponential equation, and now you see that that base of e comes into play. So, just like any exponential, you get the exponential part by itself, and then you can change forms to get the variable out of the exponent. So, what would we do first? Nigma. Let me write it larger. You want to get the exponential part by itself. Subtract 2 is good. So I have 4e to 2x equals 14. Paul, what did you do?
I couldn't tell you.
Get that e by itself.
Divide by 4.
Thank you. So now I have e to the 2x equals 14 over 4. You can simplify that or put a decimal in, either way is fine. And how do I get that variable out of the exponent? What? Not root. Variable in the exponent, the whole reason in this chapter.
Oh, change in place.
We need logs, right? We need
Yeah.
logs. So we can take the log of each side. You could do it as a change, not as a change of base, but a changing form.
Yeah, that's
You
right.
could do it that way. Let's just take the log of each side, and let's go ahead and just do it with a log base 10. Log e to the 2x equals log 14 over 4. Logs were made to get those variables out of the exponent. Why is that helpful?
Because we needed that in the exponent.
What do we do with this? Bring it down in front. So we will have 2x times log of e equals log of 14 over 4. Okay, what do I do? Letters? They are. I'm trying to solve for x. Get x by itself. Move things away from 2x. Yep, Athena? Divide by log e. Log e is just a number. So we have 2x. On your calculator now, please. Find out what log of 14 over 4 divided by log e is. First those things, keep your parentheses. Let's verify our answer. What do we get? 1.25. Do we agree?
Yep.
Yeah. 1.25? And then what? Divide by 2. And we get x equals?
0.63.
0.63 is 625. All right, and there's our answer. Okay, I want to show one other thing that we can do with this problem once we have the e to the 2x equals 14 over 4. So, we'll call this method 1. Yeah.
How do you know when to use like natural log and like the normal log?
Okay, so very good question. So, we can solve this problem using any log, as long as you're doing the same log on both sides. So if you're comfortable working with the log base 10, then do that on both sides, okay? But what we could have done, if I get another page up, so we have, when we got to the point of e to the 2x equals 14 over 4. If we did the natural log of each side, do you see the base of this exponent is e? So if we took the natural log of e to the 2x equals the natural log of 14 over 4, the natural log and e to the are inverses. They undo each other. And when they undo each other, you are simply left with the 2x. So you would get 2x equals the natural log of 14 over 4, and then divide by 2. So, if you see the base is e, you could do the natural log, and then it undoes the e to the power, and you're left with just the 2x. So that is an option.
Is there like a natural log button on your calculator?
There is a natural log button on your calculator. LN button on your calculator. Okay, so let's take a look at this one. You will have to deal with some word problems. So let's read through this. We have a spacecraft can attain a stable orbit 300 kilometers above the Earth if it reaches a velocity of 7.7 kilometers per second. I'm underlining that. That's important information. The formula for a rocket's maximum velocity in kilometers per second is this formula. V equals negative 0.0098 t plus c ln r. So now we need to know what those letters are. The booster rocket fires for t seconds, so t is time. And the velocity of the exhaust is c, kilometers per second. So this is velocity of exhaust. The ratio of the mass of the rocket filled with fuel to its mass without fuel is r. So this is the mass ratio. Okay. Suppose the rocket shown in the photo has a mass ratio of 25. So that means what equals 25?
R.
R equals 25. A firing time of 100 seconds. T equals 100. And an exhaust velocity as shown, which was 2.8. Can the spacecraft attain a stable orbit 300 kilometers above the Earth? So they're asking us if the max velocity can reach 7.7. So right now you need to plug it on your calculator. We're just plugging in values.
So V equals 7.7.
We're going to compare our V to 7.7. We're going to find V first. And then we'll compare it to 7.7.
Okay.
So we're just plugging in. We will have V equals negative 0.0098 times what?
100.
100 plus,
2.8.
sorry, that's that. Okay. All right, plus what?
Plus
2.8 times ln,
times 25.
ln of 25. So you should be able to enter this into your calculator just as easy. Negative 0.0098 times 100 plus 2.8 ln 25. Make sure you know where the ln button is. It's right below the log button. So what is our velocity? What is it? 8.03? Do we agree? So, can they sustain orbit 300 kilometers above the Earth? They have to be at least 7.7 for the estimate. All right? Questions on that one?
No.
Okay. So even though there are a lot of words, it's a simple plugging in problem. You should have no trouble with that. All right. That's it. That's it for now. Okay? The same things we have been doing. Let's get the assignment sheet up. You can write it down. Don't touch it.
No one
Don't touch it.
touched.
Fine. Good dog, bad dog, good dog. It's your future. 7. All right. Homework.
You can go fill that out.
Yeah, I concur.
I concurred first.
All right, 7-6. All right. This is the only section that, one of the two sections we're just doing one day on. We're doing 11 to 51 on page 481.
If I may use this,
No.
should I stop the video?
Yes.
Oh, man.